Algebra 2, Lesson 1-4. Evaluate homework and practice. The mapping diagram shows a function and its inverse. Complete the diagram for the inverse of the function, then tell whether the inverse is a function and explain your reasoning. All right, let's see here. Let's first give a little explanation of what an inverse is. If you have some point x, y, the inverse would be yx, okay? So let's look. We got 16 becomes 18, so 18 becomes, and that would be 16. 33 becomes 31, so 31 becomes 33. 12 becomes 48, so 48 becomes 12. 38 becomes 6, so 6 becomes 38. 18 becomes 40, so 40 becomes 18. Like I showed up here, you have some number 18, some point 85. 18, 40, that becomes 40, 18, some point. Now let's try it this way. Negative 5 becomes 1, so 1 becomes negative 5. Negative 3 becomes 9, so 9 becomes negative 3. Negative 1 becomes 1, so 1 becomes negative 1. 1 becomes 3, so 3 becomes 1. 3 becomes 9, so 9 becomes 3. And there you go. Write the inverse of the given function as a set of ordered pairs and then graph the inverse on the coordinate plane. So let's take a look at it. Negative 4, negative 3 becomes negative 3, negative 4. Negative 2, negative 4 becomes negative 4, negative 2. 0, negative 2 becomes negative 2, 0. 1, 0 becomes 0, 1. And 2, 3 becomes 3, 2. So let's graph this. Negative 4, negative 3 becomes negative 3, negative 4. Notice they're the exact same distance from this y equals x line. Negative 2, negative 4 becomes negative 4, negative 2. Notice what I need to do it. Let's do it. Let's do it. In an orange color so it really shows up. Alright. And in 0, negative 2 becomes negative 2, 0. So this, see, it's the exact same distance. 1, 0 becomes 0, 1. And 3, 2 becomes 2. 2, 3 becomes 3, 2. Notice again that each point is the exact same distance from this y equals x line. Let's try number 4. Negative 3, negative 4 becomes negative 4, negative 3. Negative 2, negative 3 becomes negative 3, negative 2. Negative 1, 2 becomes 2, 1. 1, 2, oh, negative 1, 2 becomes 2, negative 1. And 1, 2 becomes 2, 1. 2, 4 becomes 4, 2, and 3, 4 becomes 4, 3. All right, let's graph those. Negative 4, 1, 2, negative 3, negative 3, negative 2, 2, negative 1, 2, 1, 4, 2, and then 4, 3. Okay. Number 5, it says find the inverse function, the inverse of f of x for the given function f of x. Not a problem. All right. First, we're going to make this y equals 4x minus 8. That's step 1. Step 1.
Jeff, may I have your attention, please?
Step 1. Step 1, just make it an x, or make it a y. Step 2, we're going to solve for x. So let's add 8 to both sides, and we got y plus 8 equals 4x. Then we're going to divide 4 from both sides, and we got y plus 8 over 4 equals x. Swap the x into y. X plus 8 over 4 equals y. So our new equation is going to be the inverse of f of x equals x plus 8 over 4. Do the same thing over here. We've got y equals x over 3. Multiply both sides by 3. You got 3y equals x. Swap the x into y. 3x equals y. Rewrite it as an inverse. And there we go. Number 7. Number 7. What do we do first? Replace the f of x with y. Multiply both sides by 6. Subtract 1 from both sides. Swap the x and the y. And then f of x. Inverse of f of x equals 6x minus 1. This decimal's kind of tough, so let's see here. First, we're going to make that y equals, and I'm going to change this to a fraction, 3/4. Now I'm going to multiply both sides by negative 4/3. The reciprocal. And then I'm going to swap the x and the y and rewrite it as an inverse. And easy peasy. Oh, there it is. Find the inverse function, the inverse of f of x for any given function f of x. Use composition to verify that the functions are inverses. Then graph the inverse and its function. So first I need to find the inverse. So I'm going to write it y equals negative 3x plus 3. I'm going to subtract 3 from both sides. I got y minus 3 equals negative 3x. And I'm going to divide both sides by negative 3. And I've got y minus 3 divided by negative 3 equals x. I'm going to rewrite this a little bit as negative 1/3 y plus 1. In other words, I divided the y by negative 3, and I divided the negative 3 by, and that equals x. And then I'm going to swap the x and the y. Negative 1/3 x plus 1 equals y. And I'll rewrite my inverse. Rewrite it as an inverse. with the proper notation. Okay. So let's go ahead and graph this. +1, you see why I rewrote it like this. And then my slope is -1/3. So I go down 1, 2, 3, right. And there we go. It's too low. And there, that's pretty close. And there we go. That's my inverse. My original is -+3. 1, 2, 3. And then -3. 1, 2, 3, 1 is right there. 1, 2, 3, 1 is right there. And we'll draw that. One, it needs to be black. Oh, shoot. And there we go. And this, well, let's see. That's better. That's better. And I did that for a particular reason. Because I wanted you to see that this point, all three of these should meet at the same spot for it to be an inverse. Graphically, that's graphic. Now let's do it. Let's do composition. Composition is where you put one equation in another. So you got f of, that's going to be the inverse of f of x. Okay. If that equals x, then you have an inverse. And then the inverse of f of x. If that equals x, you have an inverse. Let me show you how that works. So you have f of, and what's the inverse of f of x? That is -1/3 x plus 1. Okay. So equals, now what is, that's going to be -3 and then, plus 3, and you're going to put this inverse in there. -1/3 x plus 1. All right, let's do the arithmetic now. We have -3 times -1/3 is +1, so we have 1x. -3 times 1 is -3 plus 3. Well, those two cancel out, and you're left with x. So the inverse of f of x is an inverse of f of x. Now let's try it this other way. Let me get my colors right. And this is going to be, so we're going to have the inverse of f of x. And it's going to be -3x plus 3. Okay, we want that to equal x, so let's try it. So what do we got? Equals -1/3 x plus 1. And I'm going to put this -3x plus 3 in there. -1/3 times -3x is just positive x. -1/3 times 3 is -1, and then plus 1. And those two cancel out, and we are left with x. So they are inverses of each other. Sometimes you will find one to be inverse of the other, but the other not to be an inverse of the first. It happens. Number 10. Oh. Number 10. What do we do first? Well, we got to find the inverse, right? So to find the inverse, we've got y equals 2 x minus 2. We're going to add 2 to both sides. We got y plus 2 equals 2 x. And we're going to multiply both sides by 5 halves. So we have 5 halves times y plus 2 equals x. So 5 halves times y is 5 halves y plus, and 5 halves times, that's just going to be 5 equals x. Equals x. And I'm going to swap the x to the y. Make that an x. Make this a y. And now I'll rewrite it as the inverse of f of x is 5 halves x plus 5. So I erased too much of that. Good. And we're supposed to graph this, so let's find 5. 1, 2, 3, 4, 5. And let's see, what is the slope? It's 5 halves. That would be up 5 and over 2, or 1, 2, 3, 4. And then there it is. I guess we kind of need to graph the other one, the original. Minus 2 would be right there. And then 1, 2, 1, 2, 3, 4, 5. And there we go. And again, they meet the same spot, so it should work. And we'll test the composition to make sure. We have f of the inverse of f of x. It's going to equal, well, let's see, 2 fifths times x minus 2. And in place of x, we're going to put 5 halves x plus 5. Now let's do the arithmetic. The 2's cancel out, the 5's cancel out, and we're left with x. The 5's cancel out, that leaves you with plus 2. And then we have the minus 2 here. Well, those two will cancel out, and we are left with x. Good deal. Let's try the other one. F of x. And that's going to equal 5 halves plus 5. And we have 2 fifths x minus 2. Do the arithmetic. The 5's cancel, the 2's cancel, and you're left with x. The 2's cancel, and you got minus 5 plus 5. Those cancel out, and you are left with x. So they are inverses of each other. Number 11. For the given function, determine the domain of the inverse function. Then find an equation for the inverse function and graph it. Interpret the meaning of the inverse function. Well, let's see here. The equation y geometry. The equation a equals 1/2 times 20 times h gives the area a in square inches of a triangle with a base of 20 inches as a function of its height h in inches. Okay, well, let's see here. The domain of a equals 1/2. Area cannot be a negative. It can be 0, but it can't be a negative. So the domain has got to be the domain. The domain has got to be x is greater than or equal to 0. Or in this particular case, a is greater than or equal to 0. Okay? For it to make sense in the real world. So the range of the function, the range is going to have to be, well, h is greater than or equal to 0 inches. It's going to have to be. So the inverse is also going to have to be a is greater than or equal to 0. All right, so what do we got here? We've got a equals 1/2 times 20 times h. So that's going to give you a equals 10h. So a over 10 equals h. And I guess I should be, well, so the inverse function, the inverse is going to be h equals a over 10. Now let's graph that. Well, if you put a 0 in for a, you're going to get 0. So we've got that. Let's see. What if we, let's, put in a number h. We'll put 160 in there over 10. Then that's going to give us 16. So we're going to have, here we had 0, 0. Here we're going to have 160 and 16. So those are 2 points. 160 and that just lets us draw our graph or draw our line. And there we go. So the inverse function is the height in inches of a triangle with a base of 20 inches as a function of the area in square inches. How does that help you? Well, if you look, you got 120, well, you're going to have 12 inches. 12-inch height would give you an area of 120. 8-inch height would give you an area, and it allows you to see it much quicker, or figure it out much quicker if you had to do several different ones. The label on a gallon of paint says it will cover from 250 square feet to 450 square feet. Depending on the surface that is being painted. A painter has 12 gallons of paint on hand. The equation A equals 12C gives the area A in square feet that the 12 gallons of paint will cover if applied at a coverage rate C in square feet per gallon. Okay. Well, first we need to figure out the domain. Well, the domain of the function is going to be D. The domain is going to be well, let's see. Area is area such that 250 is less than or equal to C, which is less than or equal to 450, or SA, not C, A, less than or equal to 450. All right, and then the range is going to be C, such that, well, 250 times 12 is what? Let's see, we got A equals 12C, so divide A over 12 equals C. Okay. And let's see here. So the range, well, I got the range right there. 12 times 250, 12, 0, 10, 1, 4, 5, and then 250 is 3,000. So we're going to have 3,000 is less than or equal to A, or C actually, C, which is less than or equal to, and then we got to put in 450. 450, 12, 0, 10, put a 1, 4, that's 8, 9, and then 450. So 0, 0, 14, 34. That ain't right. 12, 0, 900, and 450, 0, 0, 9, that's 14, but that's 5,400. 5,400. Okay. So we got that. Now, for the inverse, well, the inverse is going to be real easy. You're just going to make this the range and this the domain, and you're going to change that from, you'll change this to C, such that, and then less than or equal to C is less than or equal to, and this to A, make that an A, and there you go. So let's find it. Well, you got to find 250 first. If the area is, well, let's see here, 12 times 2, we already found that. We already found that. 250 and 3,000 should be right there. And 450, and that was like 50, 450, and then 5,400 is going to be right about there. And there is our graph. Okay. And I got it right off of there, 250 and 3,000, 250 and 3,000, and then 450 and 5,400. Good deal. Oh, the graph of a function is given. Tell whether the function is an inverse function. And explain your reasoning. If the inverse is not a function, tell how you can restrict the domain of the function so that its inverse, so that its inverse is a function. So let's look at number 13. How can we do that? Well, you could reflect it over the y equals x line, or, well, you can tell if something, well, let's see, if this is a function, then you can do something called a vertical line test, all right? And you can see you can only cross it at one, so this is a function. And that's with the vertical line test. Now, if you have this graph, but you don't know what the function or the inverse is yet, you haven't figured it out, you can use something called a horizontal line test to test that. And then that would be something like this right here. Well, if you notice, this crosses it twice. So the inverse is not a function. The function's inverse is not a function. And the only way to make it a function is to restrict the domain such that x is greater than or equal to 0. If you do that, then you can. Then it will in fact be a function. Okay. In other words, you would just have this one leg here. What about number 14? Well, let's do it real quick and in a hurry. We'll do a horizontal line test. All right, can we put that anywhere on there and cross it twice? No. So the functions inverse is also a function. Right, good deal. And let's try number 15. It says, identify the domain intervals over which the inverse of the graph function is also a function. Well, let's see here. The easy way to do that would be to, let's see here. Okay, so it looks like the only place it's going to work is when from negative infinity to it looks like -3, or yeah, about -3. Okay, because the inverse, let's see, the inverse of this would be something like right there. And this one would be up here somewhere. Yeah, so it's going to be about -3. Okay, and so what does that do for this? Well, according to the book, A, B, F, and G, and H are, but that is not true, because you're going to have to get below -3 for it to actually, because everything above this, so the book is actually incorrect. We'll say negative infinity to -3. Well, let's see, yeah, that's -3 would be the only place that it is, in fact, and the inverse would be a function. Good job, folks. See you tomorrow. You have a nice evening.